class, it's here. It's the last video for Chapter 4, Part 2. We are working on our second day of partial fraction decomposition. Alright, and we really have one more type to go. To kind of warm up, let's take a look. Let's remind ourselves of some of these things that we learned in last video. When we decompose a fraction, we know that we need to split the fraction based on the factors of the denominator. Well, when we look at the factors in the denominator, we have an x plus 3, and then we have an x minus 1 squared. So I need you to be very careful here. I think very easily we remember, I hope, that there's definitely going to be an x plus 3. Now, the tricky part, and the one you have to remember, is when you have a repeated linear factor, you need to also include all of the degrees, I guess, less than the total degree that I see here. So because this is degree of 2, that means I also need to include a degree of 1, and then I'll have the degree of 2. Alright, so I now know that the denominators are going to look something like this, which means I can completely get rid of A, B, and C. So now it's just up to us to decide, is it D or E? And for this, I hope you remember the trick that the numerator always has to be 1 degree less than the denominator. Alright, so here I see an x plus 3, which is linear, so I need a constant in the numerator. I see an x minus 1, which again is linear, so I need another constant. And here's the one, you just got to be careful. I'm talking about the factor itself. The factor itself is linear, which means, again, I need another constant. So I can get rid of E. I know it's going to be D. When we look at something like the next section, I'm just going to do a few of these. Maybe like B I want to do, because this is a difference of cubes. This will factor to x, 2, x squared, 2x, 4. Alright, remember it's a, b, a squared, ab, b squared. And then we're going to use SOAP to finish it up. Because it was negative, I'm going to go same, opposite, always positive. And so what we need to now look at here is, what do we have? X minus 2 is linear. X squared plus 2x plus 4, that is a quadratic, and if you remember correctly, I told you, we can never factor this, right? So the second part is an irreducible, did I spell that right? Maybe, quadratic. So that's kind of how that would work. And then the other one that I want to do right now, I want to take a look at D, x to the 4th plus 10x squared plus 25. I hope you guys remember that this is really just a perfect square trinomial. This is x squared plus 5, x squared plus 5, or how else can we write that? X squared plus 5 squared. And this is the new one for today. This is what I want you to be looking out for. This is a irreducible quadratic, but it is repeated. Alright, so a repeated irreducible quadratic. Repeated irreducible quadratic. Okay? So this, again, let's maybe star that. That's what we're going to be on the lookout for today. Now our steps, we should talk about these again. I'm going to kind of go through them quickly because I want to get started so I'm not spending too much time and wasting your weekend away. Let's see here, okay? First thing, you know it, we got to factor. Got to factor the denominator. Why do we do that? Because once we factor the denominator, we know that we're going to split the factors of the denominator into separate fractions. Separate fractions. Separate. Oh my gosh, I can't spell. Alright. Number 3, we have to place the expressions in the numerator, okay? So I'm going to just say figure out numerators. And what do I mean by that? Figure out numerators means you need to go one less degree than denom. Alright? One less degree than the denominator. So that's important. Please remember that. That's kind of what we were talking about at the very beginning of this video. Once we have that, we multiply by common denominator so that denoms cancel. And normally, you know what I'm going to do? I'm going to say we need to solve for missing variables. Alright, now last time in the last video we were plugging in x values. Plug in nice x values. It's going to be a little different today. Okay, it's going to be a little different on the next page. So let's jump into that. We're going to flip and we are going to figure out our fourth type, and that is repeated irreducible quadratics. So when we take a look at this fraction, or this rational function I should say, well, I know, and again, you could factor the top. I don't really necessarily care because it doesn't help us with splitting, but I know that I need to go x squared plus 4, x squared plus 4, or I can go even further and say this is x cubed plus x squared over x squared plus 4 squared. Alright, this is what we were looking out for, right? We have an irreducible quadratic, but it is repeated. So, what is this going to look like? X cubed plus x squared over x squared plus 4 squared? Well, some of the same rules apply as what we were talking about before, and by that I mean because this is squared, or it has a degree of 2, it needs to be represented twice, both degree of 1, right, the degree less than it, so I'm going to have an x squared plus 4, and I need to have the x squared plus 4 squared, as we see it. Now please be careful. This is a quadratic, which means I need a linear factor in the numerator, and this is also a quadratic, so I need another linear factor, or numerator, I should say. Okay? So here we go. Now it's time, your favorite and mine. We multiply by the common denominator. Well, really nicely on the left side, this is just going to go to x cubed plus x squared, because these will cancel here. When I multiply this common denominator by this, one of the x squared plus 4's will cancel because of the denominator, but I will still have an x squared plus 4 left over. Excuse me. Now when I multiply this by our last piece, or our last term, well, again, it's going to completely cancel, so I'm just going to have cx plus d. So now at this point in time, or if we were in the previous section, I would tell you to find some nice x values that would cancel some stuff out. Here's the problem. If I plug in like a 0, well, that would cancel out the a and maybe the c, or not maybe, it would cancel out the c, but then I would still have b and d, and we cannot solve equations unless you have one variable. Alright? So that's a problem. This is not going to go the same way as we had before. And basically, what I mean is that let's change colors just so you know that this is important, okay? When there isn't a nice x value, you need to distribute. Okay, sorry, I went off the page a little bit there. You need to distribute. Alright, so mark that up. So you know this is important. And now we're going to do it. Okay, we're going to do this. Let's take a look here. X cubed plus x squared equals. Now, I have ax times x squared, so ax cubed. And I have ax times 4, so plus 4ax. Then I move over. I have bx squared plus 4b. And then I still have my cx plus d. Now here's what we're going to have to do here. We need to kind of reorder this, write this in descending order. All right, if we write this in descending order, it's going to change. It's going to look like this. X cubed plus x squared equals ax cubed plus bx squared. And then I have two places with x's. So I have a 4ax and a cx. So I'm actually going to combine that. 4a plus c times x, right? 4ax plus cx means I can combine to make 4a plus c. And then lastly, I have plus 4b plus d. All right. So here's kind of the tricky part, the goofy part, the part that you kind of just have to visualize. This is more of a visual type of example. You need to understand that if this is x cubed, or 1x cubed, and this is 1x squared, this is the only piece that has an x cubed in it. This is my only piece with an x cubed in it. So what can I say about my a value? It has to be 1. A equals 1 because it matches or lines up right there. So now I already know that a has to equal 1. Using the same exact method, I'm going to say, well, this is my only piece with an x squared in it. So I know also that b has to equal 1. This is a little bit tougher, I think, than just plugging in for x, but hopefully you agree. Like, if this is my only piece with x cubed in it, nothing else over here has x cubed, so none of these other pieces are going to affect this x cubed besides this ax cubed. So that is why a equals 1, that is why b is equal to 1, and now you can kind of think through this, because do I have any x's on the left side? I do not. Okay, I do not have any x's. So that means that I know 0x has to equal 4a plus c times x. Well, get rid of those x's. Just say 0 equals 4a plus c. And what else can we do? I already know a. I already know a is 1. So 0 equals 4 plus c, or c equals negative 4. Using the same idea, I know that I basically have a 0 for a constant here. If I was going to write all of my placeholders, I would have a 0, and that is going to have to equal 4b plus d. Well, what do we know already? We know that b is 1. So 0 equals 4 plus d, or again, similar to the last one, d is equal to negative 4. And this is what we need, right, guys? We needed to figure out our a, b, c, and d value in order to properly decompose this fraction. So now we've done it. And now I just plug in to the original. So again, we write the original problem. And then we just plug in our a, b, c, and d values. So a was 1, so I'm just going to have x plus 1 over, where am I at? Sorry guys, I lost my place. Oh, okay. So x plus 1 over x squared plus 4 plus negative 4x minus 4 all over x squared plus 4, and this one is squared. Again, all I did was I plugged in my a, B, C, and D values into A, B, C, and D from above to get here. And this would be my final answer. All right? So let's do one more of these. I think these are good to practice, and again, they're a little bit trickier. And you know what? I think I'm going to try to clean this up and make this a little bit easier for you to see on this next one. So let's move on to that one. All right? Last page of our notes. We have a new rational function. Again, I'm not even going to worry about this, numerator. I'm just going to leave it, but I do care about the denominator. I do need to know how to split this. Now, I hope you know your perfect squares, because if you know your perfect squares, then we know that this is actually a perfect square trinomial. X squared plus 16, x squared plus 16, or what can we do? X cubed plus 1 over x squared plus 16 squared. All right, so now we know that we are once again in a repeated irreducible quadratic situation. So we know that we're going to have to write x squared plus 16, right? Because we want to go all of the degrees less than the degree we see. So this is to the first, and then of course we need x squared plus 16 squared. Once again, these are quadratics, so we need linear numerators. Okay. At this point, I hope you guys remember, we are just going to multiply the entire equation by the common denominator of x squared plus 16 squared. So this nicely becomes x cubed plus 1. This is going to become ax plus b, and then 1 will cancel, so I'll still have 1x squared plus 16. And then both x squared plus 16s will cancel here, so this will just be plus cx plus d. All right, now once again, let's take a look. Is there a nice x value? 0, you could try it, isn't going to work because you're still going to have both b and d. This, you can't plug anything in to get this to reduce to 0. So this is another situation where we do not have a nice x value, so we have to distribute, and we're going to kind of have to compare to figure out what my a, my b, my c, and my d values are. Okay? So to do it, we start by rewriting the left side, but now we have to distribute. So we have ax cubed plus 16ax plus bx squared plus 16b, right? That's me just distributing. And then lastly, cx plus d. Now the trick here, guys, is remember, you need to rewrite this in descending order or in standard form so we can kind of see what goes with what. So let's do that. I have ax cubed, I have bx squared, I have 16ax, and I have cx. So I'm going to write 16a plus cx. Right? That's me just combining the like terms. And then, of course, I still have 16b plus d. Now, what I'm going to do, and I hope this helps, the last one I should have probably put a placeholder in, or I should have written in a placeholder, and I didn't. So let's make sure we put our placeholders in this one, because I think that will help make a little bit more sense. So I have x cubed plus, or let's do 1x cubed plus 0x squared plus 0x plus 1. All right? And why do I do that? Because now I can very nicely see, well, this is my only piece that has to do with x cubes. So again, very similar to the last problem, I know that a has to be 1. All right? A has to be 1. What else do we know? Well, let's compare. 0x squared, bx squared, what does that tell me? Well, that tells me that b must be 0. B must be 0. Perfect. Now this is the one, and I just want you to kind of think about this with me here. I have a 0x, and I have a 16a plus cx. All right, so these are the two that have to match up or pair up together. So I'm going to write that 0x equals 16a plus cx, and just remember, this is, just get rid of the x's, right? See ya. 0 equals 16a plus c. At this point, plug in your a value. You know that a has to be 1, so 0 must be 16 plus c, or c has to be negative 16. On to the last one. Very, very similarly, my 1 is my constant, and 16b plus d is a constant, right? Both of these make up the constant. There is no x on either of these, so I know that 1 must equal 16b plus d. So when I plug in, because I know b is 0, 1 equals d, right? 16 times 0 is 0, so 1 equals d. Beautiful. I have everything. I have my a, my b, my c, my d. So all I do is I take my a, b, c, d, and I plug into the a, b, c, d from our initial or original splitting or decomposition of our fraction. So x cubed plus 1 all over x squared plus 16 squared must equal, well, my a value is 1, my b value is 0, so this is just going to be x, or 1x, right? X over x squared plus 16 plus, again, cx plus d. C is negative 16, d is 1, so negative 16x plus 1 all over x squared plus 16 squared. All right, so this was our last type, probably the most difficult type of decomposition, but again, this is something that you can do. Please remember when you're going to use this, okay? You're going to use this method when you cannot find a nice x value to kind of cancel out terms, all right? I hope this made sense. I hope you have a nice weekend. Please, please, please remember, we have a test coming up. You need to start studying for that now, or actually yesterday. So I will see you next time. Have a good one.